word recognition. So basically, this paper introduced the concept of dynamic time warping, in that people can speak the same word differently, but you are going to have the same features in when you speak the same word on a sound recording, but you might not have it, in the same time as how someone else speaks it. So an example of how dynamic time warping is that you can look at these two curves, these two waves. Let's assume that these waves are of someone speaking, and so it's the same word, but people speak the word differently, but then they still have features in common. So what we do is we try to find a mapping between these features in a way that we can find the similarities in pattern which are mapped across time. So let's say we take these two as two time series, and each time step, for instance, can be matched to one or more time steps on from one wave to the other. So so that's how they recognize a word as how it is, though these words can be spoken actually very differently. So so that's how it started, and now, of course, this technology is commoditized. It's found on all our phones and computers, so it's easy for anyone to do it. So if you're not a phone user, actually one can do actually do voice recognition on your computer in a very simple way. So all you have to do is just go on any command line with Python installed, and you just go pip install speech recognition, and you download the package, and then you can say Python m speech. Oops. Okay, so there's something wrong with this one, so I'll switch over to my backup. Sorry. Yeah, so this is actually the speech recognition library that is very easy to use. I don't know how it failed to install on my other computer, but I'm assuming it's because it's a M1 Mac. So the processor might be a bit too new for the program, but here it should be fine on an Intel computer. So after you've installed speech recognition, all you have to do is, okay, so hello SMS. Yeah, so you said hello SMS. So basically, whatever you say, they'll be able to catch it, and they can tell you what you're saying. So so basically, to create a system of considerable accuracy in this kind of thing, you need a lot of training data. So you need to actually have many samples of people saying stuff, and you have to map it to labels, like in this particular sound recording, at what point in time, you have to train the algorithm using an alignment that is labeled by a human being. So you have to know, oh, this part corresponds to which word. And and one of the easier ways which they do to which they use to collect yep. I'm sorry. So one of the places where it's easy to get a data set would be by looking at Parliament transcripts. So basically, because in Parliament, you have sound recordings of people saying stuff, and you also have people who prepare the handset to a transcript of whatever has been said. So basically, it's for many different languages, it's quite easy to just take recordings of whatever is said in Parliament and the official reports of what was said, and create an alignment and use that for training a speech recognition engine. So of course you would have to so for different languages, of course, you have to train different models because the corpus of each language is different. Every language has its own vocabulary, and so this is a website run by AlphaSafai, which is a AI company, and so basically they are developing this thing called VOSC, and they provide trained models for use in speech recognition. So you can see that there are different models trained for English, Indian English, Chinese, Russian, French, German, Spanish, Portuguese, Greek, Turkish, Vietnamese. Yeah, so for every language that you want to do speech recognition on, you have to find your training data, and you have to do your own and you have to train your models in order to perform speech recognition on that language. And of course, the Parliament data set was one of them, and a lot of other data sets exist for training such models. So so if we look at VOSC, can look at so what VOSC can give you, which is quite interesting actually. VOSC can give you so if you give VOSC and a sound recording, it can give you a JSON file that tells you for every word that it detects in the sound recording, the start and end time of the word, and the confidence of the model that it's actually the word that they predicted is the right word that they've that was actually said in the sound recording. So yeah, and so what people do with this data, of course, is this. Okay, so this is a paper about recipes. So so there are a lot of recipes for so this is an application of the speech recognition. Okay, it's a bit far off, but yeah, it's an application. So there are text recipes available online, and there are also video recipes available online. So what these people want to do is that they want to match steps in the text recipes to steps in the video recipes. So they want to know, okay, so this text recipe says crack an egg and scramble it in the same pan and mix it throughout vegetables. So someone might not know how to do it. So perhaps they're not very good in the kitchen. They might need some visual cues as to how they might want to crack an egg. So what this program tries to do is that they'll try to match parts of text recipes, and they want to map it onto parts of video recipes, so such that, you know, if someone doesn't know how to do a specific action in a text recipe, they might be able to just click on a link and they'll be brought to the correct portion of a video recipe, which will show them exactly how they might want to achieve the step in the recipe that they've been using to cook. So how they do this is that they create a transcription of a lot of YouTube videos. So they have identified actually over 4,000 dishes, and they have collected both text and video recipes for each of these dishes. And for each video that they've collected, they transcribe the video using a speech to text software or speech recognition software, and they create a transcript, and they break up the transcript into different steps, you know, and then, you know, they from a multi-model problem, they have reduced it into everything is text. So now they can do the matching with ease. And so that's one of the things that speech recognition can do. And of course, I believe in a previous talk, I was talking about a system of trying to match slides to parts of lecture videos. So that's, I guess, something similar that would not have been possible without speech recognition. So yeah. And so that was a very short talk. But any questions?
Wow, your talk really very short. But how to do? Can we develop an app to do this?
Yeah, so basically to develop an app to do this, we can either use one of the speech recognition libraries that are already available. So you would want to use that to either train your own speech recognition model, or you could even come up with your own speech recognition AI model and train your own. So you be coding that from scratch. But so I guess there are 3 levels. Like you could use someone else's models, train models. You could use someone's algorithm to train your own model, or you could just use your own algo and your own data and train your own from scratch. So I guess it's possible, but it would be a very time consuming if you're not professional. Oh, by the way, this is a shameless plug for Telegram, but let me share my screen again. And so I want to invite you to 2 Telegram groups. So so the first one is Telegram speech recognition help. So this group is for if you want to train your own speech recognition model, you can go and ask questions. So this is for beginners. So how do I do this? How do I do that? How do I find the data sets to train on? They'll be happy to help. So I think this Telegram group is maintained by people at CMU Sphinx who have created, have moved on to Alpha Sapphire to create the VOSC model I was talking about. And the second Telegram group is more for the experts who already know everything, but they just want to share what findings they have and their own their data sets and everything. So they'll be sharing, new annotated data sets for Indian English, Finnish, and whatever. So they're always training more models for more languages, so that this can benefit more people, I guess. Yeah. So.
Yeah, one question.
Yeah.
Our WhatsApp and Telegram,
Yeah.
you have one option where you can just click on it, and when you talk, words start coming out.
Yes. So yeah.
How to make it more accurate?
Okay, so that one, so the accuracy of that speech recognition model would depend on the size of the model. So I guess for Android, if you're using an Android or Apple phone, you'd be using either the model that is trained by Google or trained by Apple. The problem with these models is that in order to use a more accurate model, you want to use a very large one. So if I can show you the size of these models, so you can see that the small models can be 40 MBs. Sorry, wrong share. So the small models can be for English can be 40 megabytes. So the error rate is around 9%. All right, but a slightly more accurate model, which is with an error rate of 7%, is 1 gigabyte. So that's huge. And so 129 megabytes would give you around 8% error rate. So the thing is, if you want to put this on a phone, the phone's computational power may not be sufficient to use the 1 gigabyte model for speech recognition. In fact, a 1 gigabyte model might use too much space on your phone. So perhaps it's possible for us to improve the accuracy for the phone, but I think Google and Apple, they have chosen to use a less accurate one, but which takes up less space. Yeah.
So in your opinion, which one is more accurate, Google or the Apple model?
Unfortunately, I don't actually use the feature very much, but I do observe that my visually impaired friends, like I help a few in school, to help them write exams and stuff. I find that they prefer iPhones. So
between WhatsApp and Telegram, they use the same model from.
I think so it depends. I don't know if if it's the speech recognition that is included in your keyboard, I guess that's by the old operating system provider. But I'm not sure if Telegram and WhatsApp has that feature built in, or if they're using the operating system one. So that's in the keyboard. So I'm not sure.
Okay.
Yeah.
Actually, the features being used in the phone is quite accurate.
Yeah. So yeah.
Even you mentioned lower capacity is really very powerful. In fact, you can a lot of it could be very useful for old people to
Yeah.
realize that you can activate the phone with your voice to call for help.
Yeah. So actually, I think we have some smart speakers that do it, right? So like there's like Amazon smart speaker. You can say, "Hi Alexa," and Alexa will say, "What's up?" and then you can say, "Help, help."
No, you can actually activate the phone to call for the police or what, you know. For example, Apple, you just shout, "Hey Siri, call 999." Sorry, he's calling for.
That's the danger of having Siri on your.
Yeah, you can hear the phone being activated.
Yeah.
It's pretty accurate, you know.
Yeah.
You just shout into the phone, even it's off, and it goes to that particular person that you want to call.
Maybe the drawback of that is the phone is constantly using up its battery because it's sampling recordings, right? And then it waits until it hears "Hey Siri," and then it will act. But then yeah.
But the consumption of the battery,
Yeah.
not very high, you know.
Yeah.
That's why
So
it's the same with Trace Together. People thought that, you know, you're going to consume a lot of battery power. Not so.
yeah.
Yeah. So they should have started by saying if you have the app, they will pay you $10. I think a high percentage of people will be having Trace Together. You know.
But I guess
Manufacturing the big token to a small token.
they decided to adopt the SG secure method, right? Force every single national serviceman to install it on their phone so that we can be secure.
Mm-hmm.
So that's unfortunate. Yeah, so it's the small model is indeed good. So like the word error rate is not that much higher for the smaller model.
Yeah,
compared
it's
to the very
acceptable.
large.
You know. It's very, very, very useful.
Yeah.
Of course, it's not 100% accurate, but what you can do is just say out what you want to say, and then after that, go back and look through and
Yeah.
see whether you can correct all those errors.
Yeah. So I guess that in itself is quite useful. Mm. So let me see if I can play around with Vosk. Okay. So let's try to play around a bit with Vosk, I guess. If we can. So this is wait, okay. So this is basic. So Vosk provides API on Python for you to do speech recognition on audio files. So all you have to do is to download the VOS API and the models into a directory on your computer. And then you can just run a Python script, and then you can do speech recognition. So here, you can see that if we try to transcribe, let's say, a audio file, okay, so now you can see that, okay, we are going to talk about something, something, something. So then it'll already start generating the transcript. So it's actually quite easy to use. So all you have to do is to download, see if I can show the installation. So all you have to do is to download yeah, you just have to do a pip install, and that's good enough, actually. Yeah. So
is this Python for the PC?
Yeah, you can. So this Python, it works cross-platform. So you can do it on Linux, you can do it on OS 10, you can do it on Windows. It's all possible.
And the purpose of this is just to change your words into text.
Yeah, just to change spoken words into text. Yes.
I see. Can it be linked to maybe electrical gadgets, or maybe to do some action? You see, for example, this Siri that I'm having here,
Yes.
the iPhone. If you say, "Hey Siri, what is 2 times 6?"
Yeah.
2 times 6 is 12.
Okay.
Yeah.
So is you can talk to the phone, and then it's almost like talking to another person, and they reply with intelligent answer. Can Python do that?
So I guess you can, like, you can have a single board computer, say a Raspberry Pi, that has Python, and then you can use one of the smaller models, and you can program it to control a robot, for instance. And then you can tell the robot, move left, and then the robot will move left. Try to move right, and then it'll move right. So yeah, that's possible, and it shouldn't be too difficult to do such a thing. You just need to have it set to listen periodically for commands from the user.
Okay.
So actually, I've left the speech recognition running, and it's been picking up parts of the conversation that we've been having.
It's interesting.
So let's see.
Any idea who are the researcher doing voice recognition currently?
Yeah, so if you want to know who they are, like, just join the second group, because the second group will be all the researchers who are talking about let's see, so they'll be talking about the papers. They'll be talking about papers. Yeah, speech recognition error correction, and you have so many people working on it. And you have let's see, GitHub. You have this Indian English speech GitHub with the experiments and the scripts. So they actually have 10 terabytes of recordings, 15,000 hours of recordings of Indian English, because Indian English sounds different. So yeah, and they are sharing their problems and their algorithms and stuff. So, and their papers.
And you mentioned that this is only in the Telegram app.
Yeah, this is in Telegram. So so the first one is to seek help, and the second one is yeah, they might block you if you try to ask beginner questions, but they're still friendly, I guess. Yeah.
Interesting. So what actually happened? You just click on this link and then you will be accepted.
So you click on this link. So once you go to this link, you go to this link and then it'll ask you to open it in Telegram.
Oh,
If you open it in Telegram, they'll ask you whether you want to join the group, and you can just join the group.
okay.
Yeah. So, so if you want to like read the papers, latest papers about this, this group has a load of papers and a load of code for speech recognition. Yeah. And in fact, so there's this one about keyword spotting on ARM microcontrollers. So, yeah. So I'm sorry for the very short length of the presentation this week. Are there any more questions?
Do you know anybody working on Singlish?
Singlish. Actually, if I'm not wrong, people have actually paid Singaporeans to speak for them. I think yeah, I think I don't know specific people who are working on recognition of Singlish, but I have heard that oh yes. So let's see. A Star is doing it. So this is kind of funny, but there are Singlish speaking robots and other ways to make AI work for Singapore and beyond. Yeah, so it's basically saying that, the models are not so accurate for Singlish, and you might want to mimic a Western accent to be recognized. But well, A-Star is training Singlish AI. So so SCDF is using an advanced speech recognition system to transcribe and log every distress call in Singlish or dialect even. So that's kind of cool. and they're also using it in the state courts. So yeah, I guess people at A-Star are doing it.
What about dialects
Dialects,
in Singapore?
yeah. I think they do. Yeah, so there's a national speech corpus. So I think it's this is actually interesting. Oh, but this is English. So this is an example of a prepared data set that can be used for training your own models. This English. And this is Asian. Yeah, so this would be on Hokkien, Singapore Hokkien. And yeah. So the challenge is that for Singapore Hokkien, there's insufficient training data for them to build such a model. But so I've heard that this is 2016, but I've heard that people are actually being paid to speak Singapore dialects and get recorded for conversations. So basically they get conversation prompts and they talk about the topic and they're recorded, and that is essentially going to be used for training data to train speech recognition models for the dialect. Yeah.
Actually, for other direct, I know Tianmao, this Taobao, they have, recognized, I think the 55 direct, language in China itself.
I see. That's interesting.
Because you have this Tianmao genius, the Tmall genius.
Yeah, Tmall genius.
Yeah.
Yeah, I guess. Yeah, I've heard that not everyone in China speaks Mandarin, so they need to reach out to some more remote.
Yeah, more remote area, and then they speak direct.
Yeah.
Or other languages, because not, back in China, not everyone speak Mandarin also. In some remote places, they still have people speaking direct of their own languages.
It's yeah. Wow. Yeah. So yeah, I know. I think even Shanghai has its own dialect, right? And that's not even remote. I've heard that Shanghai dialect is quite difficult to understand for Mandarin speakers. So I think actually companies are paying through their nose to collect training data to power these applications, because this can be quite valuable. And once you collect your corpus, it's not going to go away. So in a lot of instances in AI, the problem is not about the algorithms. The problem is about a lack of training data. And so training data can go a long way to improving the performance of a lot of things. Yeah.
That's a reason why those earlier speech recognitions were actually you need to be trained.
Yeah.
Now they're moving those untrained, no need to train one.
Yeah.
just I mean they will probably recognize that.
Yeah, unsupervised lah. Unsupervised learning. You remember the robot at Discovery Center or Science Center? I forgot. There was like this robot, and you could talk to the robot. So, and it wasn't very accurate, but I don't know. That was a long time ago.
It
But
really depends on, I mean, what kind of I mean library they have, like, I mean, all the voice library.
yeah. Was it this one? The talking robot. Is it this one? I'm not sure. Oh. That I remember visiting like such a robot on a school field trip, like long time ago. And you could talk to the robot. It was so cool at the time.
They actually using this speech recognition with the chatbot technologies.
Chatbot. Yeah. Yeah, a lot of I've noticed a lot of organizations using chatbots so that they can cut down on their contact center staff, I guess. It's quite interesting. See how they're doing it. Yeah, so basically, if you have time and you want to, and you know a language that is not already here, you can try to train your own model. And and you can do it with Vosk. Yeah.
At the end, I come in late,
Yeah.
and just ask a few questions about this speech recognition.
Yeah.
First of all, you got to digitize the Hokkien, Cantonese, and Shanghainese, right?
Yeah, you have to.
When you digitize, how do you kind of, I can't imagine how you digitize the language.
So I
You
guess, yeah.
Oh,
Okay, so I guess you have to like you have to record people speaking the language, and then you have to come up with a transcript of what they actually said. So that's the ground truth, right? So when you record something, and then you have to say, oh, this is what was said, and then you have to match the part of the sound recording. You have to align it with your transcript so that when you train, the algorithm knows, okay, so this part of the audio corresponds to this word in the language. And then you have to give it many examples of how one word sounds like. And then you'll be able to find and then you apply the dynamic time warping algorithm. That's from 1978, by the way, but still used today. But that's one of the more basic ones. And you use it to note, okay, so every word in this language has distinct features. but then, you know, the speed at which different speakers speak the word is different. So how do you align it such that, you know, we warp the time and then we can match the similar features to from this sample to the other. So you know that, okay, you find this pattern in the time series. This is it.
In English, it will be in alphabet, but in Chinese, how?
So Chinese, like one word is normally one syllable, right? So
you still have a Chinese print at the same time now.
yeah, so you speak, you record in Chinese, and then you create a Chinese transcript of whatever you recorded, and you will align the transcript with the sound recording, and then use that to train.
How are we going to use it?
Sorry?
How are you going to apply? What's the application?
So the application would be, say there is, so let's say you train a Hokkien model, and so you train a model that will take in a spoken word in Hokkien as an input and a Chinese character text as an output. And then you would, and then you can, so that's the model, and then you can incorporate it in a mobile application, for instance, so that when Amma says I need help in Hokkien, like the phone will recognize, you know, the words I need help, and then the police will they'll call 999, for instance lah.
Maybe see, and I demonstrate to Dr. Ho using my phone.
Yeah.
Okay, this you can see that the phone is off, you know.
Yeah.
And then what I normally do is to say, hey Siri, call 938288897 on speaker.
Calling 938-28897 on speaker.
Yeah, it's ringing. Can you hear?
Yes, I can hear. So you can see it's so powerful, you know. If you know an elderly person fall down, you just need to shout at the phone. And this is something I normally like to share with elderly people because it's a great help, you know, to elderly people. You know, the phone is off, you know, but the moment you shout, "Hey Siri," but Siri is for iPhone. For those on Android, you use "Hey Google," and you just use the same words. They recognize it. With numbers, it's very easy, but with names, it's not so easy. So you can, let's say, instead of in cold countries, if you want to type up the words, your fingers are already frozen, you know. So a lot of times they talk to the handphone, and it's really, you'll be surprised at the accuracy that the handphone is able to give it to you. Other features that you can use with voice recognition is to switch on the fan, switch on the aircon. You just shout, you know. And you can link that with Google Home, you know. You can say, hey, Google, fan on or fan off, you know, and it just goes off, you know. So I think the next phase, if they can make it much more accurate, we no need to go and switch on the fan or switch on the phone, you know. We just shout out, and you find the fan functioning, the phone, you know, the lights functioning, aircon functioning. That's beautiful. I'm trying to learn that, you know, that is very useful. You see, For you can even ask Siri, if just again another demo. Hey Siri, give me a joke.
Did you hear they've opened a restaurant on the moon? Great food, no atmosphere.
Now the trouble, the moment you say hey Siri, all your household phone is activated. But if you are in the park and you ask Siri to tell you about the news and so on, you don't have to key in, you just shout at the phone and then they will tell you jokes, they will tell you news, they will give you news. And simple words, they will understand you perfectly, But the moment you say, hey Siri, and everyone with iPhone, all will be activated. So that's the danger. They have made it very accurate to activate a lot of phones, I mean, they more or less recognize everybody's voice. As what Ziyuan just mentioned, different people talk in different ways. But somehow this phone company have been able to roughly understand what you're saying. Previously, it's not accurate. Only now I notice the accuracy has improved tremendously. Just calling phone number instead of typing, wouldn't it be so easy, right? Like I call Dr. Ho. So these are some of the things I think voice recognition is going to help us tremendously. And one important thing I noticed in the hospital is quite a pity, they don't have dialects. And some of these elderly people can only speak in dialects. Speech recognition should be able to get the nurses to speak to the elderly people. The nurse can talk in English or in Mandarin and then change it to Hokkien or Cantonese or whatever. Cantonese, Google Translate have it because Hong Kong is using it a great deal. But Hainanese, Hokkien, not available. And these are some of the things Singapore should do it, Since we have already stopped people from speaking in dialects, but the elderly people are still using it. It should be done, and sent to Google Translate, because Google Translate is using speech recognition a great deal. And the latest thing is they are scanning words and changing it to whatever language you want it to be changed on the photographs itself.
Hey Siri,
Hey, you don't activate my phone.
transfer 1,000 to BC Lim. Your phone didn't recognize my voice.
Anyway, those with Android, you can try with Hey Google.
Hey Google, everybody transfer 1,000 to me.
I think
Google? Oh, no, I got to switch it.
I think not too long ago, there was like this Burger King advertisement in the US that tried to activate everyone's like Google or Siri or something like that.
You see, sometimes like Google, just to demonstrate Google instead of Siri. Hey Siri, open Google's app. Okay, so this is an error. Instead of opening Google app, they open Google Map. So sometimes, since I'm on Siri, so I don't bother. So if you want to get it into Google app, let's see. I can't quite remember. But I noticed iPhone, you have the advantage of using Google app and also Siri. I can't remember. Suddenly it slipped my mind because I've stopped using Google.
I think for Google, it's like okay Google.
Yeah, okay Google or
Yeah.
hey Google, what is the time? Okay, I have to open Google. I can't remember, but if you hear me say, hey Siri, what is the time now?
Mm-hmm. It's 8:33 p.m.
Mm.
Okay, so you can say, hey Siri, what is the news?
Sorry, news isn't available on the iTunes store in your country.
Okay, so news is not available on Siri, but it's available on Google. Google. If you have Google Home, it's able to recite the whole news for the day if you want it. So these are some of the amazing things that I'm seeing on voice recognition.
Mm.